Today we're looking at 5.6, which is using multiplicative inverses to solve equations. And what you need to know is that a multiplicative inverse is just simply a number's reciprocal. Okay, and the multiplicative inverse property states the product of a number and its multiplicative inverse or its reciprocal is equal to 1. Okay, so look at these that I have written down. 12. If I write the reciprocal of 12, or the multiplicative inverse, it's 1 over 12. Well, 12 times 1 over 12 is equal to, maybe, equal to 1. Yeah. 3/4 times 4/3. Again, well, if we were just going to cross out here, we get a bunch of 1s, wouldn't we? So 1 times 1 is 1. Again, -1/6 times -6. I multiply those together, I get 1. -15 times -1 over 15. I multiply those together, I get 1. So a number multiplied by its reciprocal, or multiplicative inverse, is equal to 1. And notice that both the number and the multiplicative inverse have the same sign. I don't change the sign when I do that, okay? They keep the same sign. Next, let's look at a few one-step equations. Well, what I want is the number in front of x to equal 1. So I'm going to multiply this number by its multiplicative inverse. And I'll multiply the same thing on this side, okay? This equals 1. These cancel, I'll get 1x, or just x. Okay? Remember, this is over 1, so if I multiply this fraction times this one, that cancels out. That goes to 4. -4 times 9 is -36. And it's solved. Let's look at this one. Let's multiply 5/6 by its multiplicative inverse, which is 6/5. And because I do it on one side, I need to do it on the other side also to keep this balanced. That becomes 1x over here. 5 cancels, divide by 5, that's 1. Divide 20 by 5, that's 4. 4 times 6 is 24. And we are finished. Here, the multiplicative inverse of -7/12 is -12 over 7. -12 over 7. Okay, these become 1x. This, I can cancel out. I can reduce. That becomes 1. That becomes 4. 4 times -12, -48. Okay, notice here this is a negative times a negative, which gives me a positive x. Here, -2/3, well, that's -3/2 for the multiplicative inverse. Okay, so that times that gives me a positive 1x. 1 and 3, 3 times -3 is -9 over 7, and that becomes -1 and 2/7. Okay, so there are times we are going to get fractions with these today, but that's okay. We can handle it. They're not hard. Okay, now we're going to do two-step equations. I've got two things I need to get rid of on the variable side. First thing I'm going to do is add 20. We should know how to do this, okay? Add 20. I get 4 is equal to 3/4 x. Multiplied by the multiplicative inverse, that's 4/3. 4/3, multiply both sides. Well, that gives me 16 over 3 equals x. So that means x is equal to 5 1/3. And the circle's pretty bad, but I got my answer in there, most of it anyway. Here I'm going to subtract 5. I get 1/3 x equals 6 multiplied by the multiplicative inverse, which is 3 over 1, or just 3. X equals 18. Done. Let's do this one. I'm going to add 9 to both sides. 7/8 x equals 14. Multiply by 8 over 7. Okay, I get x equals, okay, that cancels. That's 2. 2 times 8 is 16. Okay. Now let's look at this one. We're going to have to do one little step with this, an extra step. So I am going to subtract 1/2 from both sides. That's the first step. But the problem is I'm subtracting 1/2 from 5/6. So I need a common denominator. Well, it's pretty easy. The common denominator is 6, and that's going to be 3/6. So 5/6 minus 3/6 is 2/6. So I've got -2/3 x equals 2/6. Multiply by -3/2 on both sides. -3/2. Okay, x equals, let's reduce here. That becomes 1. That becomes 2. -1 over 2. 2 times 1 is 2. That's kind of hard to see with all of my cross reducing, but that's in fact what we get. Okay. Next, let's look at this word problem. Stalactites are icicle-shaped stone formations found on cave ceilings. They form from materials deposited by dripping water. Suppose a stalactite is 10 inches long and is growing at a rate of about 1/8 inch per decade. How long will it take the stalactite to reach a length of a foot? Well, how long is the question? And that's our variable. And that's how long in time, right? Well, we've got a rate right here. It even tells us it's a rate. That's pretty easy to see. It's going to be a length of 1 foot, which looks like a total to me. And this is a starting point that we have. Okay, so how do we put all this together in an equation? Well, the total, 1 foot, but I've got 10 inches here and I got 1 foot here. We need to keep it all in the same unit. Let's go with inches. So that's 12 inches. Okay, 1/8 inch per decade. X will be how long? So 1/8 inch and X go together. 1/8 X. Now X has to be decades because it's per decade. Okay, our starting point is 10. That's what we're starting with. Now we've got an equation we can solve. Subtract 10, subtract 10. I've got 1/8 X equals 2. Multiply by the multiplicative inverse or the reciprocal, 8/1. Okay, that cancels out. I got X is equal to 16. Well, 16 what? 16 decades. Well, how long is 16 decades? We can write 16 decades, or we can multiply 16 times 10 because a decade is 10 years. We get 160 years. A long time for 2 inches of growth. But that's how long this one would take, 160 years. And that will do it for 5.6 multiplicative inverses.